Welcome to grade 12 college prep physics. We're looking at some applications of high pressure water in industry. The idea of being able to use the calculations related to pressure. And you're going to see some harder questions that probably the hardest ones of the whole course kind of come out in this lesson here. Let's go with it. So first of all, hydroforming is the first process we're going to look at. And this picture kind of shows it all. This green here represents a die cut into metal, and you want to get another piece of metal that's formed to this shape. And if you kind of watch, you see the pressure, high pressure water pushes, and it forms the metal. So it's in huge, very high pressures, 150,000 kilopascals, which is 1,500 times greater than atmospheric pressure. And a little diagram. Here's the opposite view of this one, where you have a die, some piece of metal to be formed or shaped, and you have high pressure water push up on it and push it right into the die. I have a little video as well.
The hydroforming process, you set up your machine, you get the tool out required for the job, you set your machine up, you locate your blanks. Put your blank in there, you do a pre-charge, which is putting pressure on the blank to hold it to the tool to start forming, and then you set your pressures to draw. You have a top pressure, that controls a lot of your material thin out and everything. So you start the draw process, and then whenever you get to your top pressure, there's a displacement inside the chamber that allows that oil to dissipate so you don't build up any more pressure. And you draw up and you set a high limit for your draw. It'll kick the punch out when you achieve your total depth. And then you raise the dome and you strip your punch out, and then you take the part out of the press. And that's your process. It was a very unique shape. There's intricate angles to it. And working with brass is a tough part to work with, because when you draw it up, it work hardens. So then you have to do some work to it in order to be able to do some of the shapes we do, the forming we do to it. Hydroforming, you can draw the part up with pressure. You have pressure in the rubber diaphragm on top that forms the material to the size of the punch shape. And hydroforming is something that you can control your tolerances. And with hydroforming, you can go through with a lot less scratching like you do with the mechanical presses, because you don't have that metal to metal on the outside. It's a rubber diaphragm, so you can keep a lot better finish on the outside. It has a top and bottom that go with it, and we roll a bead in it and we laser some holes, which you'll see, the lasering operation, and then it gets a very high polish for a bright, it's a mirror finish. You can look right into it and see yourself. You can do various shapes better with hydroforming than you can on mechanical presses. Mechanical presses are great for round parts or something like that, but when you get into special shapes and special tolerances, hydroforming is the way to go. So we do anything from cookware, racing industry, bell housings. There's critical tolerances on bell housings. They have to pass SFI tests, a lot of them, and probably half of our business is aerospace, and we do commercial lighting, so hydroforming is very adaptable for any market. We pride ourselves on quality, on-time delivery, and at a competitive price, so we strive for the best part possible for the customer.
Okay, so just a little view of a manufacturing process, but specifically one that uses hydroforming. So keep going on our lesson here. So, some advantages and disadvantages. Hydroforming is expensive to do, but he mentioned quite a few advantages. You can recycle the water. He also mentioned no scratches, because no metal on no metal. And he also mentioned very adaptable. make lots of different shape parts this way. Okay, so there's just some advantages, disadvantages. You can write those down. The second process we're going to talk about is called water jet cutting. And basically it's just using really high pressure, high speed water to actually cut something. Okay, and let me show you what I mean.
Today we show you how to install a kitchen like this one. Step 1, click here. Did you know that water can cut steel? Water jets are amazing tools that are used to cut all kinds of materials. To learn more, How Stuff Works visited In Control Engineered Solutions in Atlanta, Georgia. The key to cutting metal with water is to keep the spray focused to a fine point. Water jets are able to cut because the spray is channeled through a very narrow jeweled nozzle at very high pressure. This essentially turns the water into a laser. To give you an idea of the kind of water pressure we're talking about, consider that the water pressure in your home is around 70 pounds per square inch, or PSI. A water jet, on the other hand, operates at around 60,000 PSI. That means the water is leaving the nozzle at speeds of more than 900 miles per hour. There's another factor that adds to water jets' cutting power. Fine granules of carbide or other particulates are mixed with water to act as an abrasive. This helps the water to saw through tough materials like titanium. Water jets are used to cut everything from granite countertops to foam packing forms. Unlike metal cutters, a water jet never gets dull and it can't overheat, so this makes it ideal for most industrial cutting applications. With the amazing power of water jets, you can see that the new Man of Steel has more to fear than kryptonite as he flies onto movie screens this summer.
All right, water jet cutting. So that's what it is. Now I'm going to show you some calculations related to both processes, and what that involves, first of all, talking about something that called volume flow rate. We give it the symbol little q, and it's just the amount of volume, in this case of water, that passes in per second, per time. So, or it could be meters cubed per minute, or meters cubed per second, or liters per second. Generally per seconds, but it doesn't have to be. So Q equals V over T. So there's a new formula we have to use. And of course that does mean you need to know the rearranged form. So V equals QT, and let's see, T would equal V by Q. So those are all the same formula but rearranged, okay? Oh, there they are right there. So in this question here, this one's not too bad. A water cutting process takes 25 seconds, during which you have a volume flow rate of 2 liters per second. Determine the volume of water. So that's not too bad, because we're just saying, okay, V equals Q times T, so just multiply and it's 50 liters. Fairly easy problem, and I know I'm going fast, but I'm going to expect you just to pause it to get everything written down. So if we're looking, however, for speed of water, and this gets frustrating because you need to be able to distinguish between lowercase v for speed and uppercase V for volume. I'm sorry. It just is what it is. But it kind of makes sense. If you know the volume flow rate, you can find the speed by dividing the volume by the area. So whatever the nozzle is or the pipe is. So we're thinking about the water jet cutting, and he's talking about, you know, I think he's saying miles per hour actually, but you take the volume flow rate and divide it by the diameter, or not the diameter, the area of the little nozzle, the tiny little nozzle. Okay. Rearrange forms again. So yeah, lowercase v is speed of water, like v is always speed. Capital case V is uppercase V is volume. So in this problem, we have a very small cross-sectional area, and that's something that comes up in this lesson, is a lot of use of scientific notation and very small numbers and some very big numbers, okay? So here's the cross-sectional area, and we know the volume flow rate, and we're looking for the speed. So like I said, it is just a divide. So, and then you ended up with a fairly reasonable number, actually. Yeah. Okay, we're getting into harder problems now. So again, I know I'm going fast. I'm just hoping that you're pausing, making sure you get everything written down, process it, write down any questions you have or what you didn't get. Put a star beside something if you don't get it. Please ask me. Maybe if you're watching this in class, you can ask me right away. That would be the best thing. All right, so in this question, look, scientific notation, to remind you that's 2, 5, and then 5 zeros after it. Okay, so that's 2,500,000 newtons is what that is. So in a hydroforming process, we have this much force applied to a piece of steel with those dimensions. First, determine the pressure in pascals and kPa. So you have to remember when you're listing the knowns here that pressure is, this is from last day, force divided by area. Okay, so in this case, we're given the dimensions. We'll have to assume it's a rectangular piece so that the area is just the two multiplied together. Okay, we know our force and we just solve for pressure. So it isn't that bad. Another thing you should do is try this, put this in your calculator on your own to make sure you can get this in your calculator without messing it up, how to do the scientific notation properly. Okay, but yeah, from pascals to kilopascals, this is just a divide by 1,000. Okay, so from here to here, I just divided by 1,000. Okay, harder questions. They're getting worse. Here we have a water jet cutting process, a stream of water. We have a speed. We're given lowercase v. Okay. I should illustrate that. I can't show you that yet, but yeah, lowercase v. We're given radius, not area, but radius. So first of all, and we have a force, and we know it's 12 seconds long as the process. So first we're looking for pressure. Well, pressure is force divided by area. In the area calculation, you find that you have the radius. You really see how this is meters? That means that this has to be in meters. And to get from millimeters to meters, you divide by 1,000. That's what I did in this step here. Then a whole of radius, so that means it's implying it's a circle, right? So the area then is pi r squared, so it's this squared times pi. So there's my area. So when I do this pressure calculation then, I have the force divided by that tiny little number. Again, it involves using your calculator in scientific notation. Okay, and then you get the pressure. In pascals, so the number comes out in pascals, and then what you do is you divide that number by 1,000 to get to kilopascals. Just like with meters, if you have 100,000 meters, divide by 1,000, you get 100 kilometers. Okay, so the volume flow rate of the water. So looking at the things that we know the area and we know the speed. So you have to have all your formulas written out, nice and neat, very distinct between your lowercase v and your uppercase v, not confusing those. Because you will, someone on your test will confuse those. Make sure you're careful to distinguish between lowercase and uppercase. But when it says volume flow rate, that's Q, and you should have on your formula sheet that that's V times A, speed times A. Okay, so then really you just multiply them out. And then it asks us for the total volume of water used during the process. And then again, it's just finding another one of the formulas that I gave you. V is Q times T, so we know Q. We know T is 12 seconds, so you can solve for it. Okay, I know it's meters cubed per second because everything I'm given is in meters. I'm doing everything with meters right now, and we're given time in seconds. So that was a big problem. A lot going on in that one, for sure. So please put a star down if you're not sure about something that I told you. Put a star beside what step in the question you're not sure why I did it or anything like that, and then raise your hand because hopefully you're in class, you can ask me right now. Okay, so that's it for this lesson, but it was a lot of formulas, a lot of new stuff to do, and yeah, that's it.